And in this video, we're going to talk about fossils. We're going to talk about the different ways that fossils develop and some just really cool fossils. Fossils are either the actual remains, a body part or a leaf, or the traces of life from prehistoric life. And again, fossils can come from either plants or animals. And we're going to see that there are about 6 different types of common fossils that we're going to talk about in detail. These are permineralization, mold and cast, carbonization, impressions, solidified in amber, and trace fossils. But if you were like me and you watched Jurassic Park as a child, you probably wanted to be a paleontologist. Paleontology is the study of fossils. But we're going to see that fossils can be preserved in a lot of different ways. Some of the time we're going to get parts of the body of the fossil. We might be able to see the teeth or the shells within the fossil. But generally we don't find the entire animal fossilized. Usually it's just going to be bits and pieces of the animal. But on rare occasions we have had entire mammoths frozen in the Arctic and mummified sloths in caves. But generally, again, we just find bits and pieces, usually the hard parts of those animals, like the teeth, bones, and shells. But some of the times we don't even find a body part. Instead, what we find are trace fossils. And this gives us indirect evidence of organisms. This just means it tells us that something was living in this area. So it could be that we have things like track marks, where an animal walked through mud before it solidified into rock. We could have animals burrowing through the sediment before it solidified, like in the upper right. Or my favorite fossil is a coprolite, which we see here on the bottom, which is fossilized poop. So here, we're not seeing the actual animal. I don't see the fossil of the animal that pooped. But by seeing things like the size of the poop, we can formulate ideas on what kind of animal it could have been. But a lot of the fossils that we see are those body fossils, where it's the actual plant or animal itself. And we're going to go over each of those types of fossilization in more detail. And the first one is called permineralization. And this happens a lot in wood. You might have heard about petrified wood, like we see in this upper image. And this happens whenever this wood turns to stone. I like to think of that story of Medusa, and anyone that looks at her is instantly turned to stone. With permineralization, we see that the organism, in this case wood from a tree, is going to change to stone as minerals start to permeate the different woody tissues and turn to solid minerals over time. So when we look at this permineralized wood, this isn't the original wood. This is all solid minerals that have changed inside of the original wood as it decayed away. So if we were to try to pick this up, instead of it weighing maybe 5 or 10 pounds, it might weigh 100 pounds. But our second type of fossil are casts and molds. And this happens whenever we have an organism that gets buried inside of the sediment. And the sediment is going to take on the outside shape and area of whatever fell inside of the sediment. We're not going to actually see that the organism itself is going to be preserved. We're just going to get an idea of what the outside looked like. But we can also, at a later time, once that organism has decayed away and the sediment holding on to its outside shape has solidified, if all of those inner parts is then filled, we'll have a cast. So if we just have the outside shape and size of the organism, it's a mold. If we have an inside kind of filling of that mold, then it's a cast. But our third type of fossil is something that's called carbonization. And when this happens, we only have a very thin layer of carbon that's deposited that gives us the overall shape of the fossil. So it's not the fossil itself. It's just a film of carbon showing us overall what the surface of this fossil looked like. It won't give us anything about its depth. But this is really, really good at preserving plants and leaves. So generally when we find our plant fossils, most of the time they are formed through carbonization, not through things like cast and mold. But our fourth type of fossilization is found in amber. And amber happens when resin comes out of trees and hardens into a solid, kind of like lava does. But when resin hardens, it doesn't destroy whatever's inside. Instead, it perfectly preserves it by sealing off whatever organism is inside of that resin from all of the air and water. It'll be perfectly preserved inside of the amber once it hardens for the rest of time. And amber is also really good at preserving really delicate organisms, like we can see with this very small spider preserved in amber on the bottom. But compared to the amount of life that has existed on our planet, the number of fossils we have is just a tiny, tiny fraction of everything that's ever lived. And that's because most of the time, fossils aren't created. Instead, the organism is just going to be broken down and decayed over time. But there are some things that can happen that will better preserve that organism and lead it to becoming a fossil. And the best thing that can happen is really rapid burial. If we look at this fish fossil, if I were to eat fish tonight and throw the fish skeleton out into my backyard, it'd be better preserved if I instantly start covering it with dirt. But it's going to have better chances if I not only cover it quickly after I'm done eating it, but if I cover a really thick layer of sediment on top of it, cutting it off from the surface. So the best thing we can do to preserve an organism so it can become a fossil is really rapid burial. But we also see that the hard parts of those organisms generally are better preserved than the soft parts. So if I didn't eat this fish, if I just threw it outside whole, animals are going to eat the soft tissues of the fish, just like I would if I had cooked it for dinner. But they're going to leave behind the bones. So we'll see that already nature is going to prefer hard parts over soft parts. Even things like vultures will come through and eat this decomposing fish. But sediment is going to help protect the organism. It's not only protecting it from air and water, it's going to protect it from any organism that might want to eat it. But overall, if an organism has hard parts, if it has teeth, shells, or bones, it's going to be more common in the fossil record than an organism that's entirely soft, like a jellyfish. So we see that our fossil record is very biased. We have a lot more fossils of organisms with hard parts, with bones, and with teeth than we do with really soft organisms like jellyfish or worms.